So, okay. All right. Hey, here we go. Let's go through a couple things here first. Okay, the first thing I want to talk about is the sine function. I want to talk about the sine function versus the cosecant function. This is one of those things I was going to do it yesterday, but we were kind of running low on the end of class, and I didn't want to just waste all your time. I want to give you some time to work yesterday. So today we're gonna cover it today. This is the reciprocal function. Now I didn't assign any of these yet. I'm putting the word "yet" in there. There's the ones that will be eventually coming down the road. That's the next section we'll be going to for 6. But the actual cosecant functions, it's what they call a reciprocal function, right? Now the big thing is reciprocal is different than a reflection. So don't think that this is the case. All right. Here's the normal sine function. It normally goes out to 2 pi, and then you cut that in half, you cut that in half again, you multiply that by 3, like that's how you find all your markers. Then the sine function goes up to the highest point, comes back down to 0, goes to its lowest point, comes back to 0. That's the normal sine function. Just drawing it flipped over is not the reciprocal, right? That's a negation. That's a negation when they do something like this. Yeah, when they throw in a negative in there, then the graph is flipped over, right? So you have your 4 hash marks going across. Again, the last one's 2 pi. You have all the same markers as before. This is pi over 2. This is pi. This is 3 pi over 2. All right. But the idea is that when you have a negative up front, this is when the picture goes upside down. The opposite way. Okay, you flipped it over across the x-axis. That's an x-axis reflection, not a reciprocal. Okay, so there's a big difference there. This is something I was hinting at yesterday, but we never got to the cosecant function. I want to discuss that today. Okay, so let's do an example of the cosecant function. Cosecant of theta. The good part is, it has the same period length or frequency as sine does, because it's actually related to the sine function. So a lot of the things that we're going to do are based on the sine function itself, and then I'll show you how they manipulate it. So we have 4 hash marks going across, like always, where the last one's 2 pi, pi over 2, 3 pi over 2. Alright, so these are my markers. It hits 1 and -1 like always. But here's the difference. Anytime your sine function hits 0, so like his sine function starts at 0, eventually hits 0 again, and then hits 0 at the very end, right? It hits 0 on the x-axis. You can't actually take a reciprocal of 0. Okay, because 0, the number 0 itself, if you try to flip it over its own fraction, this part is divided by 0, which is undefined. So how this works is when you draw the cosecant function, I actually recommend in very light pencil, like a dashed line, draw the sine function to begin with. So anytime you have a cosecant function, I'm going to draw its reciprocal function first, which is this blue one. So I'm going to put this in like very light pencil. So this is what I would do on my paper.
Why are you doing it in markers?
Alright. Okay. Yeah. Alright, so we have my function, and that's the sine graph, but we're going to do the reciprocal of it. So anytime you hit 0, there is an asymptote right there. So we have an asymptote right here, we have an asymptote in the middle, and you have an asymptote in the very back, and then it would keep going. The reason being is that you can't flip 0 over, so it would be undefined at those points. At everything else, it'll do the normal graph. So what I mean by that is it like at 1 here, like this is the highest point. When you flip over 1, it's still 1. When you flip over -1, it's still -1. So the graph for cosecant will actually cross the sine graph at those peaks and valleys. Then all it does, and this is how I remember it, it just goes the opposite direction. So So it's kind of like a reciprocal, you're flipping things over, but it's just going the opposite way. So if this one was going up over here, the cosecant graph goes down. And now once you have the blue lines drawn in there, like that's the cosecant graph, you can get rid of the dashed line for sine, because sine doesn't need to be there anymore. So I could get rid of this part, and I can get rid of this part, and that's your cosecant graph. It always goes the opposite direction that sine does.
That's weird.
Because how this would work is when you have these fractions, because these are all decimals going up to 1, when you take like a fraction like half, and you flip it over, the numbers are really big. So when you do the reciprocal of half, it flips over to be 2, so at half, the answer is actually 2 up here. So the numbers are going up. And then they're coming back down to 1 because the numbers would get smaller and smaller and smaller. But that's the idea. So that's why the graph goes the opposite direction. So again, you wouldn't need these dashed lines in here. You just need the asymptotes to be in where they need to be. Questions, comments about the cosecant graph? Now, let me do one more example, but I'm going to do some where it's kind of like what you guys are doing in your homework where they throw some numbers in there for sine, but I'm going to do cosecant as well. So you can see where cosecant would go.
Okay.
So there was one of your homework problems. I think it was something like, let's get rid of all this. So I think one of your homework problems was something like -3 sine half x, or something. It was something very similar to that. Somewhere in there, it was like either number, what is that, number 40 or something like that. It was
Something like that.
It was in the middle. Okay. So anyway, that was really weird. All right, moving on. All right. So the fourth hash marker, typically it's 2 pi, but since there was a number in front of the x, you have to divide by that number. So if I divide by half, you do their little flip, where you multiply by 2 over 1, because that's called a reciprocal. When you multiply that, so my fourth marker will be 4 pi. Now, if you're dividing by whatever that number is in front of x, something I forgot to tell you yesterday is half x is the same as this. These things are actually the exact same trig function. So if they put a half out front or they divide by 2 on your variable, it's the same as putting half out front. Whatever that number is, you divide by it to figure out the period length. That number, and then we can go from there.
What?
Who is it?
Mr. Ward. Riley, your office, please. All right, thank you. Hey, okay, all right. So fourth mark is 4 pi. We cut that in half. We cut that in half again. We multiply that by 3. So there's my markers. We're going to hit a peak and valley of 3 and -3. Because that's the 3, that's my amplitude. But now the negative out front means the sine graph is going to go the opposite direction. And that was one that I was kind of talking about yesterday, was that if they have negatives, you would go down first, and then back up, and then back to here.
So I guess the first time the marks have ever been like nice numbers, like pi, 2 pi.
Yeah. I think there was one example, I think, in the book where they actually had you divide by pi instead. And so your numbers were like 2, 1, half, and 3 halves. I thought that was kind of nice. But does everyone kind of understand how my graphs work? Now, if we're doing the reciprocal function, let's say we're doing the reciprocal function, so we're doing this. -3 cosecant half x. Let's say that that's the reciprocal function. Well, I would do the exact same math. I would draw the original sine graph, which is this one, with the same numbers involved. So I would be drawing that. But then, since I'm doing the reciprocal, I'd throw in my asymptotes where they need to go wherever I hit 0. I throw in my asymptotes. And then I would just go the opposite direction off of my graph. So the graph, if it was starting at a valley here, I would just go, and it went up, my graph would go down here. If it was going down, my graph would go up. And that would be the cosecant graph. So, just knowing how to draw sine, you can get to the cosecant graph really, really easily. So the black part is the cosecant graph. So this part I put in black, using the same numbers. So I always draw the original function, and then I would do the reciprocal after that. Okay, does that make sense? That's my little shortcut for you. The book says very, very otherwise. They try to have you memorize how to do it and where the numbers start. That's stupid. If you can draw the sine graph, you can just go off of it. but you have to, it's basically drawing two graphs in one. So,
Double point.
all right, questions with reciprocals?
Absolutely.
Okay, I'm not assigning any of those. It was just one of those things I wanted to talk about before we get to that next section. Okay, I know that this was kind of like one of your homework problems today. Just make sure you know where it's going, where the 4 hash marks are. You do have to label your pictures with all the markers, all the hash marks. I do want to see that you are labeling them and how you're drawing it. It doesn't have to be like perfect. Like all your pictures might look the same because all you're doing is changing the numbers on the graph. So it's kind of nice, unless it goes upside down, then I can see the graph. All right, questions on the first part?
No.
Okay, let's move on to the new part now. Now we're going to do the cosine graph. So new graph today. Now the beauty part of this is I don't have to do too many examples of it today. So I might do 2 examples because they follow the same rules. It has the same amplitudes, it has the same period
You
length.
just gotta use the translation.
It's just the picture looks different because it's a different trig function. So, questions on the first part here though?
No.
Okay, moving on, here we go.
Is this the brand new thing?
Brand new stuff.
Oh,
That's what
I really need to go to the bathroom.
You need to go? You better go. Okay, just go quick. Okay, when you get back, ask questions. Alright, here we go. Cosine graph. Alright. Okay, cosine function, same exact setup, but you know, the actual numbers I'll be assigning will be something like this today. And yes, I will be adding more today. Like I said I was going to warn you, I was going to add a couple cosine problems to your homework, even though it's the first day we're learning it. But it has the same numbers and the same like output basically. It's just the graph will look slightly different. So this number here still affects your origin or your shift. So if you shift it up or down, that's the only types of problems I'm going to assign. I'm not going to go the right left at all. The A will affect your amplitude. So amplitude, that's how tall the waves are. Then the V number affects the period or frequency of it. And again, the frequency is like the hash marks going across. And again, for my purpose, we're only drawing 1 period length, we're not drawing 2. So if the book ever asks you to draw 2, just ignore that, just draw 1 period, 1 picture length. Because if you need to go further, we can always figure out what the next hash marks are by adding what that first marker is. You just keep adding it on to find common denominators for the fractions. I'll explain that as we go through this. But the cosine graph is kind of new. So we're going to go draw the generic one, what cosine is. And then we'll try to do one where I plug in some numbers like the amplitude number and maybe we shift it up or down or something. Because it's going to be the same work. So cosine, same hash marks as before. We go 4 hash marks, goes out to 2 pi as always. We cut that in half, we cut that in half again. We multiply that one by 3, so it's kind of the same work. It's kind of nice that it's not really radically changing anything. We're going to hit 1 and -1 as always. But now, here's how the graph is different. When you draw a cosine, instead of starting at 0, we're going to start at the highest point. That's how cosine works. It's going to go down and hit 0 at the first marker. It'll go to its lowest point at the next marker. It'll come back up to the 3rd marker, and then go back to its highest point at the 4th marker. It kind of looks like a big U shape. Now, to explain what's happening here, it is a perfect horizontal shift of sine. So if you looked at the sine graph, sine graph looks like this, but you were to actually continue it. Right? You're actually to continue sine and it would draw a couple period lengths of it. You were to take a snapshot and shift this picture over. Like drag it over. That would be your cosine graph. It's a perfect horizontal shift.
So it's just sine.
It's the sine graph shifted 90 degrees over. So it looks weird. It looks like a big U, but it's actually a sine graph. So if you actually continue this bubble, it would just look like the sine graph going up and down. You're just seeing one snapshot of it. So it looks like a big U shape. So this would actually come back down on this side and then go back up. It would come back down over here, go back up. It looks like the sine graph has just been shifted. So you just have to remember you start at 1 for cosine. And again, how I remember that, if you use your unit circle, the unit circle we've been talking about those last couple days. Yeah, we start at 1 comma 0 because cosine is the first answer. At 0 degrees, you have to start at 1. It's the first dot. The first coordinate is the cosine answers. And then when you go around the circle, then they change. So at 90 degrees, this was 0 comma 1. So cosine was the second number, so you hit 0 at 90. So that's what it's explaining here when you actually go through the markers. Okay, questions at all about cosine? Okay, let's do an example of it where I throw in some numbers here, just a couple numbers. I want to do a vertical shift, and let's do an amplitude, because I'm not really worried about the period length. Everyone usually gets those. The period you just divide by whatever that number is. But let's do let's do a vertical shift. It can go up or down, but I want to make sure that you guys get to see how this works. So let's do an example over here. Let's go with like 5 plus 2 cosine theta. Okay? So 5 plus 2 cosine theta. It's a normal graph. They're adding the 5, so I'm shifting it up. How I know it's adding 5, this is a positive 5. If it was negative, we would be going down.
Wait, which one again is the horizontal shift?
It's when they plug the numbers in the inside.
Oh, on the back.
So, yeah, on the back. So they'll put like a plus or minus inside the radical. Or it has to be inside the parenthesis. Because I could change this problem that I just showed you here. I could put a plus 5 back here and it's still the same problem. I'm shifting it up and down. Because it's not inside the parenthesis. So, but if it's inside, then it's the horizontal shift. But for this one, I'm shifting my picture up 5. 1, 2, 3, 4, 5. So this is now the new origin line. This is where my graph is centered over. This is the center of my graph. Okay? What's the amplitude? 2. So that means I'm going to go up 2 from there. So I'll hit a peak of 7 and 3. Because that's 2 above and 2 below the origin line. Because we shifted my picture up 5. Does that make sense how I use the amplitude? So how I know I'm getting to these is because this distance has to be the amplitude. Jesus, this is a terrible problem. 7. This has to be the amp number. That's how I know. That's why I'm going to 7 and 3. Alright, so now cosine. I go 4 hash marks across. This will be 2 pi eventually. This will be 3 pi over 2. Pi and pi over 2. Okay, and then I'm going to draw the cosine graph. Alright, so, hey, so for cosine, here we go. We start at the highest point. We go to 0. We go to its lowest point. Back to 0. Back to its highest point. There you go. Okay, questions with the first part of my problem?
Oh, there it is.
Okay. I was expecting you the last time, not Jamie.
Sorry.
All right, questions at all about the cosine graph? Okay, Holden, make sure these couple pictures you're looking at, it looks like the sine graph, but you're not starting at 0, you're starting at 1 now, okay? All right, questions, comments about any of the problems? Okay, homework today, we're gonna add to it. All right, yes. Yes. All right.
Is it still
Okay.
page 533?
I love that.
It is page 533 still, here we go. We're adding 3 new problems on.
Because I used pen yesterday.
Alright, so page 533, and again, we're going to just add these on to the ones you've already done, or attempt to do so far. We're going to add 34, 38, and 50. Those are the numbers we're adding on. Okay, again, tentatively it's due Friday, so we're adding a couple more that's tomorrow. Now,
What if we don't have school?
it's fine. But hey, I might change the due date because we're gonna add some tangent problems tomorrow. And so if those are problems that we know we can't get done, that's fine. We'll just extend it to Monday and we'll just have it turn in Monday. But let's say weather related, it's due whatever day we get back then. Okay. Tentatively next week on Monday and Tuesday, I'm tentatively kind of going to do the review of the next major test we're going to take. I'll give you the practice guide. I don't know if we're gonna necessarily do it Monday or Tuesday, we might do it like Tuesday, Thursday. The review, and then we'll take the test Friday. I just don't like doing that, but I just wanna make sure you guys are well aware of the test coming up. About a week from now-ish, we have attended test. I don't know how many questions it will be, because we haven't done too much in this chapter. I would expect about 12 questions again. Some triangles, some angles, some of these trig function stuff, Pythagorean theorem. So it's not too bad. You do have to convert angles and stuff, you have to remember that. What? A lot of Pythagorean theorems. Alright. Alright, that's it for today. Yeah, the rest of the time is yours. You can move around. This Hag, how are you? I haven't seen you forever. I know. Oh, you're selling more cookies? Yeah, heck yeah. Some peanut butter cookies. Delicious. Yeah. You got s'more cookies now?
Yes.
Those new?
Yes.
Thanks a lot. Pretty good. How much are these?
$4 a box.
Oh, that's not bad. So, okay. Let's get some s'more. I want to try one of those. And I love it. $12. I think I got $12 on it. You want cash right now?
My favorite, zeros 2.5. They were like back when zeros was like.
I heard what my mom did to you.
When are you good?
What are you talking about now?
And when I was
When she wrote on a piece of paper and just wrote both and was like, here, you go.
Oh. Yeah.
Yeah. Alright, Kobe 9. Kobe 9.
Thanks.
You're welcome. See, I figured for cookies you wouldn't mind me.
No. Anytime. You can stop in anytime.
Well, I know, but I'm like always working, so like I'm supposed to be in Ames right now, but my doctor is sick. So I'm not working today.
Alright, fair enough. Fair enough.
I don't
I need to buy some shoes, so I'm probably gonna stop.
Okay.
Yeah, too much.
I got two Kobe 9
Well, Mom, that it's not my
Yeah,
work.
I have Kobe's. I'm gonna wear
And I asked her if she gave you a hard time about you buying the monsters because they're not healthy. She always yelled at me when I got it.
I can't even look it up.
Alright, I'm gonna go visit more teachers, take some more classes.
Good seeing you. Appreciate it. Like there. Okay. Who did this? Who did what? Who did this, you guys? Oh, my name on a piece of paper, just blank. No, it's going to be though. I have pictures on my desk. I'm gonna put in 5,
Mr. Ward,
13.
Reese told me that he's gonna steal your book if you don't let him take cookie cutter.
Literally, I'm just sitting out.
No, say that you just talk in the third person.
Why is this page
It's on my desk right now.
Mr. Ward. Mr. Ward.
Mr. Ward.
Yes.
Justin says he's not gonna give you your book unless you let him play cookie cutter.
What? No, I'm not being blackmailed for cookie cutter.
It's under Holden's desk.
Is that what I mean? Wait, whose desk?
It was under Holden's desk. I don't know if they moved it.
The geometry. I didn't.
Maybe that's why he was
gonna let you go to the bathroom.
Mark's just gonna have to do it on his floor. I lose it.
I'm gonna make this place my kitty live.
I love the question. So bright.